uh, give you a pretty good understanding of what that function actually does. Now, starting with the point creation tile, I'm going to select the point. The point creation tile activates a sub palette. The sub palette has tiles that activate dialogues. So we go at 3 levels. We start with the main palette, go to a sub palette, and go to a dialog to define a feature. We're going to start with the XYZ tile. This is called the explicit tile command. With the explicit tile, we can define a point anywhere anywhere in space using the X, Y, and Z vectors. Inputting values into these dialogues locates the point on the screen. Let's start with a point at X2, Y2, Z0. We typically draw the geometry at Z0 and control the depths of the cut with the actual machining or the cutters. The X2, Y2 location is typed in, and I click on the single feature creation tile. You notice that the sub palette has 2 tiles. One has 2 points, one has 1 point. The single feature creation tile will generate the point, as you can see, and return to the top level palette. I want to create another couple of points. Go back to the point tile, X, Y, Z, and let's put one at X minus 2, Y2. This time, we're going to use the multiple feature tile. By clicking on this tile, it generates the point and keeps the dialog window open, allowing me to continue inputting locations for additional points. For example, I'll type in minus 2 in the Y. And once I'm in the multiple feature creation mode, I can use either the Enter key or the space bar to generate additional features. Change the X to a positive 2, hit the Enter key, and I get a point. Let's put one at 0, 0, X0, Y0. This time, I'm going to use the single point creation tile in order to generate the point and return to the top level palette. If I turn off my origin marker, you'll see that I do have a point at 0, 0. Now, going back to the point tile, we see that the second tile on the sub palette is the point at an angle to a point, or commonly considered to be a polar point. The polar point tile places a point at an angle and a distance to a pre-selected point. For example, if I needed a point at 35 degrees, 2 inches away from this point, I would activate the function, the polar point function, brings up the dialog window. The letter P allows me to select a point, identifying it with the reference label. The letter D represents a distance. I'll put in a distance of 2 inches. And the letter A determines the angle. I'm going to type in 35. The angle of 35 degrees is based on 0 being at 3 o'clock on the clock face. In the counterclockwise direction, we go to 35 degrees, and we click on the single point creation tile, and the point is generated at the correct location. Going back to the point tile, we notice that the third tile is for a bolt circle. The bolt circle creation tile will generate a complete or full bolt circle or a partial bolt circle, depending on whether this checkbox is active or not. A full bolt circle gives us a set of dialogues. When I uncheck full, I get an additional dialog that identifies the angle, the starting angle of the partial bolt circle. Let's go back and do a full bolt circle. Let's specify a radius of 3.5. Z0, and we're going to place 8 holes around this particular bolt circle. Now, the center of the bolt circle is specified by the X and the Y values. And I'm just going to make a quick new work group for this bolt circle here. Come back to my point, bolt circle, and my settings are retained. X0, Y0 is the center of the bolt circle. This particular dialog, the little degree sign here, determines the known location of the first hole of the bolt circle. For example, if we want this bolt circle to reference off of 12 o'clock on the clock, we would type in 90 degrees here. If we wanted to start at 0 degrees, type in a 0 here. This would locate the first hole and properly space the remaining holes around that circle. I'm going to type in a 90 degrees. I'd like my first hole to be at 12 o'clock. These two radio buttons control the direction of the creation of the points, clockwise, counterclockwise. For a full bolt circle, the direction is really inconsequential. If you're doing a partial bolt circle, then you'd want to pay more attention to the actual direction of the point creation. If I hit do it, move my dialog, I see 8 points on a 3.5 inch radius bolt circle. Pretty straightforward. Specify the radius, number of holes, center position, starting angle of the first hole, do it, you've got a bolt circle. I'm going to go ahead and close this. Dialogs can be closed either by clicking on the X in the upper right corner, or if they're active, a Control W will close the window. The next feature that we see on the palette is the matrix command. Let's generate a matrix, but first I'm going to delete the bolt circle. So I'm going to click on screen, do a Control A to select all, and hit the delete key. All the points are eliminated or deleted. Let's create a matrix. Come over to the matrix dialog, activate it, and we're going to see that at first glance it looks a bit confusing. Now let's understand what a matrix is. A matrix is a series of holes lined up in a row, which could be either vertical, horizontal, or at an angle. To define the attitude of the holes, we use these input dialogues. Anytime you see a dialog with a triangle to the left of the text input, we are dealing with an incremental value or a delta value. This dialog box is delta x1, and this governs the spacing of holes along a row in the x-axis. If we wanted a straight row of points or holes, delta x1 would be 0. If we wanted this row of holes to be at an angle, we would type in a value here, and each hole would incrementally move from the previous hole to the positive or the negative direction as specified here. Delta y1, if we follow the dialog, the arrows from the dialog, determines the center distance of point to point along the y-axis. The count along the y-axis determines the number of holes. The Y is the absolute start location of the first hole of the matrix. The X is the same thing, the absolute start location of the first hole of the matrix. We have the count along the x-axis, determines the number of holes along the x-axis. Delta x2, distance from center point to point along the x. delta y2, any deviation along the y-axis. If it's 0, it's a straight row. Any amount in here, the points would increment upwards or downwards. Let's generate a simple matrix. First, a straight matrix, then we'll generate an angled matrix. Delta x1 is going to be 0. That is going to specify a straight row. Delta y1 is the center distance from hole to hole along the y-axis. I'm going to type in a minus 0.5. The fact that it's a delta or incremental value requires us to put in the polarity, positive or negative. Number of holes along the y-axis is going to be 5. Center position, start position of the first hole in y is going to be 0. In x, it will be 0. That will place the first hole of the matrix right at 0, 0. The count along the x-axis will be 3. Delta x2, center distance, point to point along the x-axis, will be 0.5. Delta y2 will be 0 to create a straight line or a straight row. We'll say do it, and we get a matrix that has 3 rows, 5 holes in each row. Here's the count of 5. 1, 2, 3, 4, 5. 3, 1, 2, and 3. Center distance 0.5 from here to here. Center distance 0.5 from here to here. Now that's a straight matrix. If we wanted to generate a matrix at an angle, all we'd have to do is type in a value right here. Delta x1, type in 0.125, do it, and the matrix is created at an angle with each point incrementing in the positive direction 1/8 from the previous location. Control Z, make that value a minus, and you see the matrix lean in the other direction. Control Z will make this value 0. Change delta y2, make that 0.125, and do it. And then we see the y-axis incrementing upwards by 1/8 of an inch, point to point. Minus 0.125 and do it. Goes in the other direction. And there's also a feature called outline right here. Let me make this 0 again. If I check outline, notice this picture here changes to show only the frame of the matrix. By selecting outline and saying do it, we generate just the outer points or the outer holes. Nothing in the center is generated, and we can do a frame for maybe a part that requires a series of holes around the perimeter. Okay, so that's the matrix dialog, and I'm sure you all know that we can do math in the in all the windows. Like for example, if we wanted to do a trig function, sine, cosine, and tangent are generated by using the letter S, C, and T. If I type in the number 45 and the letter S, it gives me the sine of 45 degrees. If I type in the number 60 with the letter T, here's the tangent of 60 degrees. The number 30, the letter C, there's the cotangent of 30 degrees. And the letter A is the inverse. Let me do a tangent. Let's go 30 tangent And the letter A is the inverse arctangent, gives me the angle. Once I have the tangent, I can go back to the angle with the arctangent. We can do square roots. 64, the letter R. The square root of 64 is 8. We can do pi, the letter P with the equal sign is the pi value. And we could convert inch to millimeter and millimeter to inch simply by typing in a number, say for example the number 1, hit the letter M as in Mary, and it converts to a metric value. Type in 12.7, the letter I for inch, and it converts that to inch. So you can use any of those initials or letters to do math or trig functions in any dialog box. It doesn't have to be this one in particular. It could be any dialog box within the system. So it's pretty handy for doing your calculations in the dialogs when you're creating geometry. I'll go ahead and close this up. Delete the matrix from the screen. And the next tile of the point subpalette is the center point tile. I'm going to go back to my first work group simply because I've got a series of points there, and it makes it easy to generate a circle where you have a pre-existing point. So I'm going to click on the circle, circle with the center point, pick a point, and generate a circle. Now, the reason I did that was just to simplify the circle creation. I'll now delete the point in the center of that circle and generate a center point. Point tile, point creation subpalette, select center point, click on the circle to identify it. You see the label here. For viewing reference labels, Control L will activate labels. And I see a C1 here. When I selected the circle, the reference appeared in the C text input. I hit the single circle tile, and I get a center point referenced as 0.6. 1, 2, 3, 4, 5, and 0.6. Circle 1. Okay. Let's delete that point, Control Z, and we'll delete that circle also. Control L turns off labels and allows me to view the points without any labels present. All right, back to the point tile. The next feature is a midpoint, or a point midway along a selected feature. This midpoint works well on circles and lines. Let me draw a circle and a line just to illustrate. To a circle with the center point, but this time I'm not going to pick a pre-existing point. If I need to draw a circle without a point at the center location, I can click on the CP tile, get the pull down portion of the menu, and do a point at X. I'm sorry, a circle at X2, Y0, Z0, and generate a circle there. And then we will just make a line from here to here, just to have a couple of features to illustrate the midpoint function. All right, we go back to the point. Midpoint, a midpoint is generated in the center or the middle of a selected feature. If I select this line and generate a midpoint, it comes up right in the center of the line. If I do a midpoint on a circle, it places it right at the midpoint of the circle or the arc. So for generating points midway along a feature, this is your option right here. Next feature of the point subpalette, point on an arc. Point on an arc, I'll go to another work group just to keep it clean. Point on an arc does just that. Puts a point on an arc using the center point value, 0, 0, 0, and the angular values in x and y. Positive and negative vectors are selected here, and the radius is input right here, along with the angle. Let's put one using these default values. And there's the point there, right at 45 degrees on a 1-inch radius. Change the angle, 60 degrees. Notice how the X and the Y dialogues update to show the distance of the location. You say do it. There's a point at 60 degrees. Let's do one at 30 and change the radius to 2 inches. And do it. And we get it out here. Okay, so that's pretty straightforward. Point on an arc. The remaining feature on the subpalette is the mouse point. Click on mouse point, and you can track the location of the cursor using the X and the Y registers. If I place it here at 0, 0, the register reads 0, 0. Here's that point at 0.7, X 1.7, Y 1, and that location is based on the grid spacing. It rounds off to the nearest 100,000ths based on this value here. If I change this value to 0.01, check the location. Notice that now I am defaulting to tenths or 10,000ths. Change this to 0.001. And if I can even change it to 1/10, I'll get the exact location of this point within a tenth. Now, the mouse point also lets you place points using this register and clicking on screen. Every time you click on screen, you generate a point at that location. Changing the grid determines the accuracy of the placement. Changing the Z will generate the point at the given depth, minus 0.5. I'm going to click here. From the top view, it looks like it's at Z0, but if I look at it from the front view, notice that I do have a point below the top surface at minus 0.5. Okay, let's go back top view. All subpalettes have the return command right here in the lower right corner. This returns you to the top level palette. You click on here and goes back up to the top level palette. The points are going to be deleted. Click on screen, Control A, and toss them in the trash. All right, let's play with some lines. We're going to work with some lines here. I'm going to go back to work group number 1. And I'm going to delete this line right here. I'm also going to delete this circle. The line creation tool generates the subpalette with different options for generating different types of lines. We've got a line between 2 points, a line at an angle to a selected point, a line at an angle tangent to a circle, a line parallel to a pre-existing line, a perpendicular line through a point, an axis line. The axis line is the ability to generate vertical lines along the x-axis horizontal lines along the y-axis. And then we have a similar function to what we had in the point tile, which is the mouse line. Clicking on the screen, dragging a line, and clicking again generates the line and anchors it with terminator points. Excuse me. Let's generate a line between points. Let's go with the line between 2 points. I'm going to place a line here to here. Multiple line. And it generates a line through the points extending from one edge of the defined stock to the other. Another line, point to point. Single line. And you see the same situation. The line is generated through the points, but it extends from one edge of the stock to the other. There is a function in the view menu that is called extend lines. Extend lines checked. The lines will extend as you see on screen. If we turn off extend lines, go back to the line creation tool, line between 2 points, select 2 points, like so, generate the line. The line does not extend beyond the selected points. This is handy when you're generating a large amount of features and you want to keep the drawing a little bit cleaner. This way you don't have lines extending beyond the selected points. I can place another one between these 2 points. And it goes from this point to this point without extending to the edges of the defined stock. And again, this is located in the view menu, extend lines. All right. So your option, you can extend them to the edges of the stock. What it does is it trims, when you connect the lines, it trims anyway, but sometimes it's better to do the shorter lines. And you can see, sorry about that, guys. You can see that the line does not extend beyond the 2 points. Okay, back to the line creation tool. A line at an angle through a point. Now, previously, with Control L, we saw reference labels. If I want a line at maybe 30 degrees, or let's say 35 degrees to a given point, I select the point, and I see the label in the text input. See that? P7, P7. If I don't have an existing point, I can generate the point here, or I'm sorry, specify the point here and do it in the same manner as if I had picked the point. So let's go with P7, an angle of 35 degrees, and do it. And we see an angle line at 35 degrees. Notice again that it extended from one edge of the stock to the other. If I turn off extend lines, line at an angle through a point, pick this point, do it. There's the difference. This is extend lines. This is don't extend lines. All right, view, turn on extend lines once again, and go back to the line creation tile. Okay, the next feature is going to use a circle. So I'm going to make another circle with the center point, CP. I'm going to place this point at x minus 3 and do that. Here's my circle. Line at an angle, tangent to a circle. Select the circle, and I'm turning off labels. And give it an angle of 45 degrees. Do it. you get two lines on screen. It's up to the user to select the line he wants to keep. You select the desired feature or features. If I want to keep both lines, I select them both and say, OK. My arc is trimmed and connected to the lines, but it may not be in the right orientation. In gibbscam, when you trim an arc or connected arc, it always snaps to the less than 180-degree side. Sometimes it's correct, other times it's opposite of what you expect. If the result is not what you expect, you can toggle the arc by selecting it, going to the Modify menu, and telling it to reverse the arc. This reverses the direction of the arc and corrects the orientation if it's incorrect. If we're doing slots, you may have to flip one of the arcs over. All right, back to line. A line parallel to an existing line. This feature requires us to select a pre-existing line, such as this one, or any line, and it asks for a distance. I'm going to type in a distance of 0.5. Choose the single feature creation tile, and I get two choices. Once again, select the desired feature or features. I'm going to select this one here, say OK, and this line appears or stays on screen. But you notice that it's not a duplicate of this line because I had turned off or turned extend lines back on. And so now the line is extending from here to here. What we're working towards is connecting some of these lines. That's why I'm leaving a lot of these on screen. Back to the line. A line perpendicular to a line through a point. This feature is handy for generating lines perpendicular to an existing line through a point. Like for example, this point and this line. I'm going to delete this line for clarity. I want a line perpendicular to this line going through this point. I select the point and the line. Single feature creation. And that line is at perfect 90 degrees to that pre-selected line. Line, axis line. Axis line, as I previously mentioned, is the ability to generate vertical lines along the x-axis, horizontal lines along the y-axis. Vertical lines are placed along x, and I'm going to make my z value 0 because I always draw my geometry at z0 and do my depths with the tools. X 0.5, we should see a line ½ inch away from 0, like so. X minus 0.5, line on this side. Horizontal lines along the y-axis. Let's go y minus 3. A line down here. Y positive 3 places a line up here. And, quite a bit of clutter here. So let me delete some of this stuff. Okay. Then we have mouse line. Mouse line lets us draw lines using the mouse tool by clicking and anchoring the line. And you notice how the line can be manipulated in any direction. And we're using a grid or snap grid spacing of 100 thousandths. So every placement of the line is within 100 thousandths grid. The lines are generated and connected as we draw them. By placing the endpoint directly at top of the start point, we connect the feature and release the line from the screen. Show you that again. Throw this away. Line, mouse line, anchor it, move it to a given location, and you can see where you're drawing by using this register right up here, X and Y. Let's you pull it, and you can draw a perfect rectangle by watching the values, or you can get into a more free form look. Like so. And again, you can draw using this X and Y register and control the precision or accuracy with the grid spacing. Okay, we'll return to the top level palette and we'll throw away this geometry. Okay, we're going to generate some circles. Now circles, as you saw, can be created using the radius and the center point. And let me go to a new work group. Get cluttered here. Keep it cleaner here. Well, circles, circle with the center point and a radius. In the case of not having a center point, you click on the CP tile and you specify the center point in X, Y, and Z coordinates with the radius value, and you draw your circle like so. If we had a series of points like so, and we wanted circles at all those point locations, we could select a circle with a center point. With the control key depressed, I'd pick all the points. And by clicking on the single feature creation tile, I would generate circles at all the point locations. So this kind of speeds things up a little bit. If you've got a series of points, go ahead and pre-select all the points and then build your circles on those points. Get rid of that, and we'll get rid of the points also. Back to the circle tile. Circle with the center point through a point. Okay, I should have left one of these points up here. I'll leave a couple. Circle with the center point through a point. The center point is going to be 0, 0. No, I'm going to make it x2, y1, z0, and the selected point will be this point here. Create the circle. The center point is here, and the circle goes through that point. The radius is based on the distance from the center point to the selected point. Back to circle. Next tile, circle through 2 points with a radius. Let's select this point and give it a radius of maybe, let's say 1 inch. Or no, we'll give it a radius of 2.5. 2.5 inches. Do it. Get two choices. You select the circle you want to keep. You say OK. And there is a 2.5 inch radius circle going through the two pre-selected points. Let's see. The next feature is a circle tangent to three features. I'm going to force a circle tangent to three of these features here. Go here, here, and here. Do it. I'm able to select the one that is tangent to the circles that I selected. For example, I want this one. Say OK, and that circle remains on screen. Now, I want to show a little bit, before I get into predefined shapes. We've done points, lines, and circles. Now, what we need to do is go back to workgroup number 1 and do some connecting. I'm going to throw this stuff away here, right here. Connecting is one of the issues that we encounter when we first learn the system, that we have to understand how gibbscam connects or trims. In gibbscam, to trim two features or to connect two features to each other, you must first select one feature, hold the control key, select the next feature, and hit the connect button. There's a couple of variations to connecting, but that is the fundamental method of connecting. Pick one feature, hold the control key, pick a feature that intersects or is tangent to the pre-selected feature, and click on the connect button. To illustrate, you pick one feature, hold the control key, pick the second feature. Now these features intersect, so they're able to be connected. Click on the connect tile. A blue connector point appears at that intersection. The line that had the initial connector point to the arc turns blue. Connected geometry will be all blue. Terminated geometry will be all blue except for the two terminator points. Unconnected geometry will be yellow. All right, I'm going to connect this to this using the same technique. Pick one line, control click the intersecting line, click on the connect tile. That made the entire feature turn blue, and it is now connected. If you were to run a cutter on the outside, it would know to turn the corner at each intersection or connection. I can run it on the inside as a pocket, and this would be the boundary. Okay, another approach for connecting is hold the shift key. This will turn the cursor into an area drag marker. You drag this cursor with the shift key depressed over the intersection, release the mouse, and both features select. When using the shift drag method, any feature within the window will become selected. Having selected the two lines, I keep the cursor on the geometry, I right mouse click it, and I tell it to connect. The pull-down menu on the right mouse click has four options. The last one is connect, disconnect. We click on that, and we generate a connector point at that intersection. Do the same thing down here. Shift, drag a small window over the intersection, right mouse click, connect. Shift, window, right mouse, connect. Shift, window, right mouse, connect. Okay, that's pretty easy also. Shift, window, right mouse, connect. Saves you a click or two from having to go up to the the connect tile. Now, let's talk about terminating. I'd like to terminate this feature here, make this an open slot so my cutter can come in out here and do a contour on the inside and come out. So I'm going to delete this line here. And I'm going to terminate this feature at these 2 points. Terminators are generated the same way as connectors. Control click the line and the point and connect. Or, like the previous method, shift window the point and the line, right mouse click, connect. This is now an open terminated feature. My cutter will start anywhere I like outside the feature, come inside, and come out to anywhere I specify on the cut as it leaves the feature. Okay. Now, throw away these points. There's another method that we can use for connecting. Using the point tile, we can control click 2 features. The reference labels appear in the text inputs. I select the multi-feature creation tile to keep the window open. It generates a point, and then I can just go down the line, connecting intersection after intersection without the need of the shift window or the control key. So you activate it one time, and then you just select features and connect them. This is handy when you have a large number of features that you want to connect. When doing 1, 2, or 3 features, you may revert back to the shift, drag, right mouse click, connect method. So just to illustrate that again, let me delete these points. And this has its use. Point, take the 2 lines, take 2 lines. And once you're in multi-feature creation mode, you can actually use the space bar and save another click. One of the nice things about version 9.0 is that we have the multiple undos. Control Z, Control Z, Control Z, Control Z, Control Z, Control Z. Notice I go back as far as I like. Control Y is the redo. So you've got some nice functionality there. Now you've got the multiple undos where you can go back to a previous action and start over or redo from that action on. Control Z, undo my connections, and I'm back to my geometry or my construction lines. The Shapes tile brings up the sub palette. In the Shapes tile, you can generate engraving. We'll cover engraving at a future date. I don't want to get too involved with this. Offset. Offset is handy. The offset function allows you to pick geometry, give it an offset distance, an accuracy, do it, and you get an offset on both sides of the selected geometry. You can keep both pieces of geometry, or you can double click the one you don't want and throw that away. Closed shapes, any shape can be offset. All you have to do is select it, and do it. The predefined shapes are a box, or basically a rectangle, polygons, ellipses, gears, and cams. I'm going to open a new work group, or go back to work group number 2, and I'm going to delete everything from this work group and generate some predefined shapes, starting with the box. In the rectangle dialog for the box, we can specify the size of the rectangle or box. I'm going to generate a box that's 4 inches in X and 3 inches in Y. The center position determines the placement of the shape. Center position 0, 0, 0 places the shape right at center. Control Z, change the X value to 2, do it, and the edge is placed at 0. So understand that the placement of the shape is determined by the center position of the shape relative to absolute 0 of your part. We have the added provision of doing fillet radii. If I select the fillet, type in 0.5 to make it nice and visible, do it. I can generate a rectangle or a box with fillet radii. Uncheck it, do it, and you get the square cornered box or rectangle. For pocketing, for boundaries, this shape is pretty handy. Polygon, this is slick. Polygons are multi-sided shapes. The number of sides is determined right here. I'm going to do a hexagon, do a 6-sided shape. The distance to flat and distance to corner determine the size of the polygon. This is a radial distance from the center of the polygon. Distance to flat is from the center of the polygon to the flat of the geometry. Distance to corner is to the corner of the geometry. For wrench flats, typical mill machining, you'd want distance to flat to specify the distance across the flats. When doing turning on a lathe and you're turning stock to put a hex on with a milling cutter, then you'd want to go distance to corner. This would ensure that the diameter was large enough to allow for the flats of the hex. 6-side polygon, distance to flat, 0.75. Center position, X0, Y0, Z0. Do it. And there's our polygon. Distance to corner, 0.75, should give us a distance of 1.5 inches across the flats. I pulled up the dimension palette, threw a quick measurement on there to verify. Undo that. Another method for verifying geometry, one that I prefer to use, is the mouse tool. Right mouse click on the geometry, go to mouse position, and in mouse position, you can measure locations and distances using the cursor. In the mouse tool register, you've got the ability to go to 2D or 3D control. 2D control for flat work, 3D control for geometry that has depth, or when you've extracted geometry from a model and you have 3D geometry. Now, what I like to use is this delta display right here. X, Y, Z the angle, and down here is the hypotenuse of the measurement. Let me illustrate. By picking a point on the polygon, I get a red triangle at the beginning of the ruler. Notice that as I move my cursor, the registers update. I pick this point here, and my x distance is 0.86603, my y is minus 1.5, my z is 0, the angle is 60 degrees, shows 300. 360 minus 300 leaves 60, so that's a 60-degree angle, and the length of the hypotenuse is 1.73205. So I've got the distance in x, the distance in y, and the angle and hypotenuse across here. So it's a handy little tool. Control Z. Let's do a polygon with fillets in the corners of 0.1. Do it. And we see that we generate fillets in the corners. Control Z, get rid of that, and unzoom. Now, the sides, let's do an octagon. Eight sides. Let's do a triangle. 3 sides. A nonagon. 9 sides. So pretty straightforward and nice for generating fully connected polygons. All right, the next tile is the ellipse. The ellipse, same rule applies as polygons and boxes. We're dealing with the center position. The x radius, 2 inches, y radius, 1 inch. Do it. Generates an ellipse. I'm going to turn on labels. Notice that we see a B1. An ellipse is not a circle or an arc. An ellipse is a B-spline. This shape is defined by a series of short, straight lines. Okay? In the case where I want to machine this part or this shape and minimize the amount of code that I get, because a B-spline will generate a large amount of moves, or G-code. It'll be a series of XY moves all the way around. There's a bunch of straight line XY moves around the shape. A lot of code. If I want to minimize my code and generate G2s and G3s, the way to do this is to select the spline. Notice that it's a B-spline. Select the spline, go to Modify, Segment Spline. We can segment this spline into analytic geometry, whether it's lines or arcs. I'm going to select arcs. Do it. Notice the labels now have a series of points and circles. So now we've replicated that ellipse as a series of arcs. This will generate a lot less G-code, a tremendous amount of less G-code, and give us G2 or G3 moves, depending on the direction of our cut. So this is handy for minimizing the amount of code going out to your machine. Doesn't alter the shape, it simply converts it from B-spline to analytic geometry. So delete that. All right, a gear. A gear is generated based off of gear data on your blueprint. I'm going to use the defaults simply because I don't have any gear data handy. And you can specify the pressure angle of your gear. Addendum and dedendum, these are values above and below the pitch diameter. Addendum is above, dedendum is below the pitch. Top fillet, root fillet. Orientation could be an internal or an external. Diametral pitch, circular pitch, pitch diameter, number of teeth. all gear data from your blueprint or from Machinery's handbook. All this information, again, gear data supplied by the blueprint or Machinery handbook. Gear type can be a gear or a spline. If I say do it, it generates one tooth of the gear. I then go to the modify menu, duplicate end, 2D rotate comes up as a default, 30 degrees comes up as a default, and 11 times comes up as a default. 11 times because it has 12 teeth, and we've drawn the first one. I say do it, and we've generated our gear. We could then end mill it, or if we had the wire EDM module, take it into wire and profile it with a wire. The cam module lets you define the lobe of a cam. We draw the lobe, you draw the rest of the shape. Uniform velocity, harmonic, side load, modified sine, the tolerance. Give it a start radius, an end radius, start angle, end angle, clockwise, counterclockwise, do it. And there's the lobe of the cam. You would then use your tools to draw the balance of the cam, whether it's on a crankshaft or whatever the application might be. Okay, let's go back up to the main palette. Throw away this this cam lobe, and I'm going to show you how to generate a spline or a curve. A curve is a B-spline. We saw that ellipse previously. That ellipse was a B-spline. Now in gibbscam, we can generate a curve or a B-spline through a series of points. Points are defined using hard numbers from your blueprint, or in this demo situation, I'm going to use mouse points. I'm going to create a series of points. Oops. Just like that. Then I'm going to generate a curve through those points. 3 choices. Polyline generates lines between the points. Spline fit generates arcs between the points. And spline control points, I would generate a B-spline and use control points to control the shape. The tolerance setting, 0.001, and I've selected spline fit for the best fit, and then the curve selection could be either chord length, uniform, Foley's, or centripetal, different types of splines. I'm going to select a uniform spline. This gives us our best fit, best result. Then I pick the points in the order that I want the spline to flow through them. I'm picking them one at a time. I could do a select all, but it may not give you the results that I was looking for. Create the spline, and it generates the spline through the points. If I turn on labels, we see that that is a B-spline. Look for my B, there it is. B-spline right there. So you can make 3D shapes by generating points and then putting a spline through the points. Oops, got away from me there. Automatic chamfer, automatic radius. Going back to my previous work group. Turn off labels. And I'm going to connect this box right here. And I'm going to delete this to keep it a little clearer. And we'll delete this stuff here. All right, the automatic chamfering radius tool is activated by, you notice that it's inactive at the moment. It's deactivated until we select a point. The point selection is done, and we can now click on the chamfer tile, and we've got 4 options. We've got fillet, chamfer defined along the side, a chamfer defined along the depth, and a chamfer defined along the length. Let's use all 4 tiles on these 4 corners. So what we're going to do is generate a radius that's a 1/2 inch by selecting the circle here. We get a 1/2 inch radius right there. In this corner, I want a chamfer. I pick the point, chamfer tile, chamfer along the side. I'm going to leave the value at 0.5 to illustrate how the distance changes. 0.5 along the side. There's our chamfer. It's 0.5 from this imaginary point to here, from here to here. Chamfer in this corner. This time defined along its depth. Same value. Notice how much larger it is. This time it's measured along the depth from here to here, to the imaginary point. And one more corner, defined along its length. 0.5, same value. This one is shorter than the other two because it's 0.5 from here to here. So my suggestion would be to draw your geometry sharp cornered, and then you can put in your automatic chamfers and radiuses as you see fit, as you need them. So doing it this way maintains the connections and eliminates the need to have to go in there and draw points and tangencies and then connect. The next feature on the tile is geometry from solids, which we'll cover at a later date. Connect tile we covered, and as I mentioned previously, Geometry Expert will be covered in its own separate webinar where we can devote sufficient time to understanding how this function works. With that, we'll end it at this time. I'll start taking questions. I can answer questions. If you'll just raise your hand, I'll go ahead and start taking questions. Thank you for attending, and we will have more in the future. We will advertise and notify you guys when we'll have them. Again, thank you.